In 3.5, we're going to talk about how to write equations of lines. So we're going to focus on the learning target here. I can write the equation of a line given if I have the slope and the y-intercept, or given if I have the slope and a point that is on that line. So the equation of a line, if we go back to algebra, we know that the slope-intercept form of the equation of a line is y equals mx plus b. When you have y equals mx plus b, when you have an equation such as this, we know that the slope is the m value, and we know that the y-intercept is the b value. So whenever you have any type of equation that is in that format, this y equals mx plus b, for example, y equals 3x plus 15, we know that we can, from this equation, we can grab a little bit of information like this 3, which would be considered our slope for the line, and then the 15, the positive 15, which would be the y-intercept, where it crosses the y-axis. So if I wanted to sketch that out real quick, I know it's going to cross the y-axis at a positive 15, so I'd have to count up to the positive 15, and I can go ahead and plot a point, and then I can use my slope because that tells me how steep it is. So I can do my rise and my run, 1, 2, 3 over 1, plot my points, and sketch in my line. So write the equation of the line when m is equal to -2 and b is equal to 5. So if I wanted to write the equation for the line that fits that criteria, I know that y equals slope times x plus the y-intercept. So if I'm given this information, if I'm given the slope of -2, I can go ahead and fill that in. And then if I'm given a y-intercept of 5, I can go ahead and fill that in as well. So this is the equation of the line that fits this criteria. So now how about writing the equation from the graph? Well, if we think about the last slide I knew what the slope was, and I knew what the y-intercept was. Well, from this graph, I can find those two pieces, or I can get those two pieces of information. So the m, the slope, is going to be your rise and your run. So find two coordinates. There's a coordinate right here, and there's a coordinate right here, and then figure out your rise and your run from between those two coordinates. I'm going to start at the bottom left coordinate, and I'm going to go to the top right. So I would have to rise 1, 2, 3, 4, and I would have to run a positive 1. Both of those are positive numbers, so my slope is equal to 4 over 1, which is 4. And then my y-intercept, take a look at where your line crosses the y-axis. The line crosses the y-axis at -1, -2, -3. So my b value would equal -3. Well, now that I have those two pieces of information, similar to what I did in the last slide, I can take those and write out my slope-intercept form. Y equals, I'm going to replace the m, and then I'm going to replace the b value. Now you can put plus -3. This right here would be the exact same thing as if I put 4x minus 3. Both of those mean the exact same thing, so both of those are correct. So y equals 4x minus 3 is the equation of this line on this graph. So our m we figured out was 4, and our b we figured out was -3. So the equation of our line, the y equals 4x minus 3, is a little bit cleaner. That's the one that I would use. I most likely wouldn't put plus -3. So write an equation of the line that passes through the point 2, -3, and has a slope of 6. In this problem, we know what m is, but we don't know what that b value is. So the way that we can figure out the b value is we can use the equation for point slope form. The equation for point slope form is an equation that you learned in algebra. But just to refresh your memory, point slope form is y minus y1 equal to m times x minus x1. So when you have this setup, when you have this format, what you can do is you can replace what you have with the information that you're given. So if I have a point, that point is going to become my x1, y1. And if I have a slope, I'm going to go ahead and replace my m value with that slope. So when I work this out, it should come out to slope-intercept form. So we would have y minus, y1 is negative 3, so y minus negative 3 equal to 6 times x minus 2. And now this just requires a little bit of algebra here. So y minus a negative 3 is the same thing as y plus 3. A negative and a negative make a positive. I need to get rid of these parentheses if I'm going to continue working this out. So I need to distribute the 6. This becomes 6x. This becomes negative 12. Now if you continue this on and you continue working it through, you should hopefully get it in this format, y equals mx plus b. So I would subtract the 3 from both sides. And when I do that, I get the y by itself. And then I have my mx. And then I have my plus b value. And I now have it in slope-intercept form. So even though we weren't given a b value in the initial problem, because I was given a coordinate and because I was given a slope, I'm able to use this point-slope form in order to be able to come up with this final slope-intercept form. So the equation of the line that goes through the point 2, negative 3 and has a slope of 6 would be y equals 6x minus 15. This one again has a point and it has a slope. So because it has a point and a slope, I would again use that point slope form, y minus y1 equal to m times x minus x1. So take your x and your y and plug those in for x1, y1, and then take your m value and replace m with negative a half. So y minus a negative 4 equal to negative a half x minus 3. Now a negative and a negative make a positive, so let's change it to y plus 4. Take this negative and distribute it through your parentheses so we can get rid of those, so we can get rid of the parentheses. Negative a half x. Negative a half times negative 3 would give you a positive 3 over 2. So multiply those two together. A half times 3. 3 would be the same thing as 3 over 1. That gives you 1 times 3, which is 3. That gives you 2 times 1, which is 2. So it gives you 3 over 2. And now we can clean this up because we want to get it in that slope-intercept form. So to get it in this slope-intercept form, I would subtract the 4 from both sides. And we get y equal to negative a half x minus 4 minus 3 over 2. If you're trying to do that in your head or if you're trying to work it out by hand, in order to subtract those, they'd have to have the same denominator. So 3 over 2 minus 4 over 1. To give the second fraction the same denominator, it would have to be a 2. So I'm going to multiply the top and bottom by 2, and I get 8 over 2. 3 minus 8 gives me negative 5 over the common denominator. So this, when you work this one out, you get y equal to negative a half x minus 5 over 2. So in slope-intercept form, the line that goes through this coordinate and this slope is y equals negative a half x minus 5 over 2. All right, so that gave you a couple examples when you're given a point and a slope. So first off, if we go all the way back to the beginning of the lesson here, we started off by taking a look at m and b, and then we took a look at what happens when I have a graph. How do I come up with the equation of the line? And then we took a look at what happens when I only have a coordinate and a slope. Well, now we're taking a look at what happens when I only have two coordinates. So what is the equation of the line that would go through these two coordinates? Well, we've been focusing on m and b, and from these two coordinates, we can't figure out what the b is, but we can figure out what m is. So to figure out the m, we can take and subtract the y's, 12 minus negative 2, negative 3 minus 4. So remember y1 minus y2, excuse me, y2 minus y1 over x2 minus x1. 12 plus 2, that would give us 14. Negative 3 minus 4 would give us a negative 7, so our slope is negative 2. Now, if you think back to the last slide, actually the last two slides, we have a slope and we have a coordinate. And you can use either one of these coordinates. It does not matter which one you pick. You'll end up with the same answer. So pick either one of those coordinates, and then we would have y minus whichever one, doesn't matter. I really don't want to work with the number 12, so I'm going to pick the smaller numbers. So I'm going to go with this one over here on the right. So y minus a negative 2 equal to negative 2 times x minus 4. If you just have a slope and a coordinate, when you have a slope and a coordinate, remember you can use this point slope form. Y minus y1 equal to m times x minus x1. So when I plug in my values, and you can use either coordinate, doesn't matter which one you pick. I picked the second coordinate. So when I plug those in, go through and clean it up. A negative and a negative 2, y plus 2. Distribute the negative 2, and you get negative 2x plus 8. And now get the y by itself. So you end up with y equal to negative 2x plus 6. This is the equation of the line that goes through these two coordinates. All right, so we'll stop there, and then we'll pick up with how it ties a little more into the geometry piece here in the next one. So the primary focus in this video here was how do I write the equation for a line when I'm given coordinates, or when I'm given a graph, or when I'm given slope and a point. So there's many ways that you can be given the information and then calculate what the equation of the line is.